Hello everyone. In this video, we'll be solving the question write hash map, which as the name suggests, is actually a way to write a hash map from scratch. So before we move on to the actual approach to this problem, you might be seeing some variables k, v, etc. Don't get intimidated, it's nothing new. It's just a generic way to handle variables in Java. Since a hash map can have, well, a pair of data types, for example, whether it's integer and string, or string or integer, string boolean, or boolean integer, so on and so forth. This k and v is basically a generic help that Java provides to us. And that's basically what we're using to implement a hash map for any data type. Now, coming to the hash map itself, as you may have seen earlier when you were solving questions on hash map, these are the main functions that we use inside a hash map, which are usually inbuilt for us. But in this particular question, we are going to write the code for them for scratch. Now, the functionality for these is such that if a value is already present in the hash map, say a hash map is a hash map has two particular values. One is the key, second is the value. Say one is India with its value as 20, then there is Pakistan, value as 17, then there is UK, which is 15, there is Nigeria, which is 29, so on and so forth. We have our key and value pairs. Now, suppose a value is already in the hash map. This is a hash map. What it does, the put function, what it does is that it simply updates the value. If this value is not present, say I want to put Finland and 11 in it, it will put this new value inside the hash map. It will insert the value. For get, if the value we're trying to get is present, then we will simply pass the key and get the value. If we pass UK, we'll get the value 15. We simply return the value. If not, if the value is not present, say for a country, Russia, the value would be returned as null. For contains key, if a key is present, say if I search for India, India is present, I simply return true. Otherwise, I return false. For remove, if the value is present, I take the value out. Say I want to remove Nigeria, take the value out, I return the value, and I remove the key value pair from the hash map. If the value is not present, I return null. Similar functionality as compared to get, but in remove, the value is well removed from the hash map and you can't access it again unless you put it back inside. Now, the key set simply returns us all the keys, that is India, Pakistan, UK, Finland, in a list. And the size, well, gives the number of elements, that is 1, 2, 3, and 4 in this hash map. That's basically all the main functions of hash map, and we're going to implement them. How, you ask? So basically, the hash map that we'll be implementing will implement an array of linked list. This will look something like this. This is an array with its indexes and all of that. And in each index, we will find a linked list. And inside the node of a linked list, we have our key and value pair. So on and so forth. And basically this will be a pointer, as is the case in a linked list usually. And that's basically the implementation we'll be trying to approach here. So for that, let's start with the function put. Let's try to implement the function put. The basic concept is that, say, when we are using a hash map, we use the function map dot put, and I want to insert UK with its value as 15. This is what we use in a hash map. So what this does is that this UK key and value pair is sent to a hash function. It's going inside our hash function, which is a black box right now. We don't know how it works exactly, but we send our value key in it, and it returns the index, some index from our array of linked lists that we had drawn. It sends one index, say it says that you can go in index number 1, and so I'll go there and I will do two things. First, I will loop inside this index. Now, a better way to call it would be a bucket, actually. Every index is a bucket. Let's call it a bucket. We will loop inside the linked list that we will find in this bucket. So there's a linked list of elements here. We have it, and say India 20, blah, blah, blah. Now, we say that UK has to go in index 1. This is what a hash function has told us. So what we do is go to this bucket index inside our array, and we loop. Now, while looping, we'll check if the key that we are encountering currently is this same as the key that we're trying to put here. If it, and let's, all right, we'll get that later. Okay, so we'll see if it's the same or not. If it's not, if we don't encounter any key that is same as the one we're trying to put, we insert new node UK and its value 15 will be put here. But if I try to put this again with the value 16, say, it will go to the bucket. So this hash function, basically, for a particular key, it always returns the same index. It never changes for a particular key. So we'll go in the same bucket again. We loop through I, P, N, and then UK. I found the same key. I will update its value with the new value that I've entered. That's basically how this put function works. Now, I would, at this moment, I would like to talk about the other functions first. That is the get function and contains key and remove. They're basically very similar to the put function. If you understood the functioning of this put, you will certainly understand how get, contains key, and remove works, because we'll do a similar procedure where we in our get function, for example, so in a put function we enter a key and a value, as I just explained. In a get function we just enter a key, right? And same is the case with contains key and remove function. And while doing that, what we'll do, we'll enter the key in our hash function, same as before. It will return us an index, and then we'll go to that index inside the bucket. Then we'll loop. In get function, we loop. We'll find UK. Suppose we are trying to map.get UK. We'll get UK here, and the value that we find on this particular key is returned as 16. 16 will be our answer. And well, if the value is not found, say I enter Finland, and I get the bucket index as 2, as that is the only bucket that Finland could be found in. Say the index is 2. I go into this index, say there are a few values here, assuming could be Antarctica, could be Utopia with their respective values. I search for Finland here, I don't find it. If I'm not able to, I return null, as I explained here. That's basically what we do. I do the same thing In the remove function, the only difference is when I'm searching for a value, say I'm searching for UK again, searching for UK. If I find it, I'll return the value 16, but I'll also remove this node from my linked list. That's basically what we're doing. Lastly, we have contains key before the other two functions. In contains key, we simply we loop, we send it to the hash function, we send the key, we get an index, we search the bucket for our value. If we find a key, we return true. If we are not able to find a key, we return false. And that is basically the function. And the way this works is quite simple. But before that, let's discuss key set and size. Key set is basically returning all the keys in the entire hash map, and size is returning the total number of nodes. And while we're on the topic, let's discuss something about the complexity. So these functions that I'm talking about, these functions are actually supposed to work in constant time complexity. And that constant time complexity will be implemented in such a manner that, say we have a value small n, which is total number of elements, and we have capital N, which is 4. This capital N is the number of buckets, that is the number of indexes that we have in our array. That and the 4 will be the number of linked lists that we have in our hash map at the moment. Now we get a value lambda, which will be small n by capital N. This will represent the average number of elements per bucket. Obviously, I mean, it's a pretty simple formula. And so every time we traverse through a bucket, I shouldn't have erased that array to explain it better. But every time we traverse through a bucket now, we will go through an average number of lambda elements. And so that will make our complexity for any function, which basically follows the same procedure as O, big O of lambda. That is the complexity that we will be following. Now this lambda, to keep it as a constant value, we keep this lambda to be less than a certain threshold. For this question, I'll be taking that threshold as 2. That is, on an average, I can't have more than 2 values in per bucket. Of course, there can be more in every bucket, but on an average, throughout all the buckets, I shouldn't have more than 2 values in each bucket. And so basically, now that we are going to implement all these functions, we're going to need some helpers. As I had discussed, first, we need a hash function. We need a hash function to, well, get the index at which we will find our linked list to insert, remove, get, etc. Then we need a get index function. Get index within bucket. Get index within bucket will basically get us the value, the index of our particular key inside the bucket, right? So if you're able to find a key, say we have a bucket, okay, so we'll get our bucket index using our hash function. That's pretty clear, I'm assuming. And with that bucket index bi, I traverse, say this is the bi, this index, I traverse through the list that is present here. And if I'm able to find my key, say my key is this particular index, 0, 1, 2, etc., I will return this index 1. That is, within this bucket, on the first index, I was able to find my key. And so it will return this value. If it is not found, it will simply return -1. And there are these two functions. Then there is another function. That function would be used to rehash. What does rehashing mean? Rehashing basically means to see the number of buckets that we have, 4, double that amount, go up to 8 buckets, say 1, 2, 3, 4, 5, 6, and 7. We have 8 buckets now. Sorry for the handwriting. Now we double the size, and then we reinitialize all of these nodes that are kept here. And we would do that by using the put function. We already have a put function that inserts these key value pairs inside a hash map. That's basically what we'll be using. Now you may ask, why do we need a rehashing function? That is because we need to maintain this lambda. We need to keep this lambda equal to 2 or less than or equal to 2, which is the number I'm using at the moment. For example, if I have these 3 nodes and on top of that I have, say, 2 nodes here, then I have 2 nodes here, then I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have, say, 8 nodes at the moment. So small n would become 8. Number of buckets is 4. So our lambda would be 8 by 4. This is equal to 2, which is an appropriate amount of threshold, less than or equal to our threshold. So this is an appropriate number for lambda to be. But I say that I want to put another value in it, say here. Now the small n becomes 9, and 9 by 4 is not 2. This new lambda, 9 by 4 becomes 2.25, which is more than 2. We can't have that. Our complexity is increasing because of it. So what we do is that we double the size. We make a new hash map. We double the size of this hash map, and we put all of these nodes one by one. Say that goes here. This goes here. This goes here, and say one node goes here, one node goes here. Now we have again 1, 2, 3, 4, 5, 6, 7, 8, 4, 7, 9. We have 9 as we had just calculated up here. We have 9 nodes, 9 key value pairs. Total number of buckets is equal to 8. And so this new value becomes, I think, 1.125, or it's definitely less than 2. So basically, we see that this is how we can keep our complexity low by using a little bit more space. And basically, we have to implement all these functions to implement our hash map properly, all of them. And to help us, we need these 3 functions. That's what we're going to do now. We already have some skeleton functions. Let's make, say, our hash function. This hash function is public. We'll return an integer, that is the bucket index. Hash function now we keep an integer hash code. This hash code, and also we'll be entering our key here, right? Since we are looking for a bucket index for a certain key. So we get key dot hash code. Now you may be wondering what this hash code function is now. I didn't really talk about it before. So this hash code function is basically a hashing function. I've explained what the hashing function is. This hashing function is given to us by Java. Let's consider it a gift. It's a black box. We don't need to understand how it works at the moment. But this function will return us the same bucket index for the same key every single time. So if I enter UK or India, it will give us the same values that it has been giving us for UK and India respectively every time we call this function for a certain key. Now this hash key could actually be negative as well. So hash code, sorry, this hash code could be negative as well. So what we do is that we convert it to a positive value, and this value can be anywhere from 0 to infinity now. So, but we don't need that. We can only have our indexes from 0 to less than our number of buckets, right, for our array. What we're going to do is we're going to return hash code modulus buckets dot length. Buckets is our array that we're initializing. That's basically how you write a hash function. But before we move on to the hash function, let's go over to the helper function that we already have. This is our HMNode class. This will store our key and value pair. As I discussed earlier, this is the generic helper for key and for value. This is our constructor. The size will represent the total number of elements represented by small n, as I was using for my dry run. And this buckets is our array. And well, capital N will be buckets.length, which we can calculate at any moment. And then init buckets is the function that we have to initialize this particular hash map that we have in the form of array of linked list. And the initial size will be 4. Whatever we put in this value, in this parameter, that is the size of our, well, hash map. And that is what we will use while we are rehashing. And by this time, I'm assuming you've understood why we still need to rehash. And now that we have that, we can go forward and try to get our index from within a bucket. Get idx within bucket, a long function name. For this, we need two things. One is our key. The second is the bucket index. Of course, we'll be searching for this key within that particular bucket index linked list. So within the linked list found at that bucket index, I'm sorry. So for this, we can have a data index that we'll be returning at the end of the day. And now we need to traverse. So traversing is of this form. We have, say, HM node that we will find inside our bucket, and the index would be bi. The list is of the form HM node if I'm not wrong. Yes, it is. So in our linked list we'll get the type HM node, which is a key value pair, and so we'll check if we need a variable HM node pair, third pair for now. If pair dot key equals the key that we have sent as a parameter, we return our data index because we have found it here. Otherwise, we move on to the next data index to search for it. And if we exit this entire loop, we simply return -1 as a symbol that we have not been able to find this key in the index that the hash function gave it to us, and it's not possible to find it anywhere else. As well, the hash function gives a constant value throughout. Now, we need another function called rehash. Called public rehash, and the type will be void as we're not really returning anything. Now we need a hash map of this type, that is linked list HM node. I'll just copy this from here, and let's call it old buckets, as we are storing our previous buckets in this particular variable. Now, these old buckets will be doubled in size, right? So we need to use this function init buckets, and this n will be double the size of our old buckets. I had already explained why in the dry run. We have init buckets, the size will be old buckets dot length into 2, twice the size, and the new size of this particular hash map will be 0. And now what we'll do is that we'll traverse through the entire hash map what we had previously and put each value into the new hash map. So for I is equal to 0, I is less than buckets dot length, we go through each bucket one by one, and inside each bucket we go through every pair of values within the linked list. And what we do is that we put the value in the new hash map, the key for which will be pair.key, and the value will be pair.value. That's basically what we do here. Now that we have our helper functions intact, hopefully, we can start with implementing our hash map properly. Now we have our put function. For the put, the rules are simple. We have our bucket index, which will be given to us by our hash function. I think the spelling is correct, with the F is capital. Hash function. We'll send the key there. Then we'll get our data index for our key, which is found using get index within bucket. I have to first pass the key, then the bucket index. Now that I have that, I check if my data index is equal to -1. That is, if I have not found this particular key inside that list in the particular bucket index, I will insert my new value there. That is, I will add my value buckets bi dot. Oh, we need a new node for that first. hm node hm new hm node, and we can use a constructor here. So we'll say that our new value would be key value and bucket index dot bi dot add hm, and if that is the case, we increase the size. Otherwise, if we have been able to find the same key inside our hash map, we will simply update the value buckets bi dot get di, that is the value that we'll find at that index is the same as our key right now, and we'll change the value to the value we have right now, and there's no need to change our size in this case. Now here we will have to check if our lambda is appropriate or not. A lambda will be of the form of the data type double. This lambda is equal to size divided by buckets dot length. I'm sure you can catch up why, but we will simply do this particular operation here so that the value remains in double and not an integer. Otherwise, say 9 by 4 would give us the value 2, which is inaccurate for us. We need the whole value 2.25, right? This is what we'll do. Now if this lambda is greater than 2, that is, lambda can be less than or equal to 2, but it can't be greater, right? So if lambda is greater than 2, we will rehash. And we've already handled rehashing properly, I hope. So that's basically what we do in the put function. Now, if you're able to understand why this put function works, you will definitely understand how the others work. Pretty simple. Take this code here. This part remains the same. Now, if we are not able to find a key, we will simply return null. Otherwise, we will return this value that we have. That's what you do to get your certain key value pair, set the value with your key, and if you have to check, and the remove function is very similar with very small differences. Let me just paste it right here. Now, if we are not able to find our key here, that means it does not exist, so we return null. Otherwise, we store the value. This is the value we store. This is the value that will be returned as well. But we also need to remove this value, that is buckets remove the index at which we found our value, and we return this value. Contains key is even simpler. If we are able to find the key, if you are not able to find the key, we return false. If we are able to find it, we return true. Now, these are the two functions. Size seems to be pretty simple. We simply return the size. Speaking of which, I did miss a point where when we remove something from our hash map, we also have to take care of the size. We have to reduce it by 1. And I'm hoping I did the same with put. I increased the size. I did. And I updated it to 0 when we're rehashing it. Now, coming to the key set, we have to return an array list of type key. So let's define it. The type is k. Keys is equal to new array list. So now we traverse again through our entire hash map, sorry. Now we simply add our key to this particular set and we return it. And our approach seems to be complete. Let's see if it works fine or not. And it's a pretty lengthy code, so there have to be some errors here and there. Now, okay, there's semicolon missing. Let's see what else. We cannot be converted to integer in line number 120. Okay, that's because the type is generic. It's not really an integer. And I'm afraid I might have made this mistake somewhere else as well, but let's check that. Exception, of course. So while we are putting a value, we are throwing an exception here. And we'll have to do the same thing while we are rehashing. Wrong answer. Let's try to analyze this and see what's wrong with it. The issue could be that we're actually traversing over the new set of buckets instead of the old set of buckets that we had just initialized. So it might give us a wrong answer quite naturally. Let's see if this gives us the right answer. Still gives us the wrong answer. That could be because we didn't really change this particular thing and it's accepting now. And so when we try to submit it, we see that all of our test cases may just pass fine. And they are. That's basically how you implement all of these functions. So going over them quickly one by one, we have our hash function, which will return us the bucket index at which we are supposed to find our key, or maybe not find our key in certain cases. Then there is our get index within bucket, which is for we search with the key, we take a bucket index, we look for our key there. If our key is present, we return the index at which we'll find it within the linked list inside that bucket. Otherwise, we will return -1. If our lambda seems to be increasing, that is whether adding this certain element will increase our complexity or not. If it does, we rehash it. That is, we'll increase the size of the new hash map to double so that we can keep the lambda as small as possible, so that we can keep our complexity as small as possible. Then we put our value in this way. We take out our bucket index using hash function, then we get our digit index, data index, and we are able to find it. If we did not find it, we insert the key value pair. Otherwise, we simply update the value. In the get function, we have our same concepts right here. If you're able to find the data index, we return the value, otherwise we return null. If you're able to find the key, in case of contains key function, we return true, otherwise return false. In terms of remove, if we're able to find the key, we remove it, we decrease the size, and we return the value that we are removing, otherwise we return null if you're not able to find the key. In key set, we simply store all the keys from the key value pairs inside an array list and we return them. And in size, we simply return the total number of elements, total number of key value pairs that we have at the moment. And that's basically how you solve write hash map. And thank you so much for watching. If you found this useful, leave a like, drop a comment, and do subscribe to our channel. Thank you so much for watching.